All right, find your NOVA app in the Physical Sciences folder. Everybody got their volume turned down? Okay, Kenny. Volume down. Everybody should be right here.
All the way down.
All the way down. You'll turn your volume back up here in a little bit when you get ready to do the activity, but we don't need this guy talking to all of us at once. Everybody here? All right. Let's review real quick. Atomic number. If we know what the atomic number is, what else do we know? What particles? Keely?
Atomic mass.
We know the atomic mass too. Sure it's the atomic mass. Peyton? Parker? Peyton's your sister, right? Parker.
No, Peyton's my
Cousin. Well, just shake your head if I say Peyton. Okay. Parker?
We know the number of protons and electrons.
Okay, so because we know the protons and the electrons are the same as the atomic number, how do we find, oops, you guys don't want to go off there. How do we find the number of neutrons? What's the formula for finding the number of neutrons? Get on, Peter, you know what it is. Atomic mass minus
Protons?
the number of protons. That gives us our number of neutrons. And remember how we saw the model last Friday? How the protons and the neutrons were inside the nucleus and the electrons orbited around the outside? Well, today, you are going to build these models. You're going to build these models. So touch on Explore up there at the top of the page. Your screen should look like this. A nice, pretty periodic table. Here's what I want everybody to do. See right here, boron. I think boron's the one we want to do first. We're going to do boron first. So touch on the B for boron. Everybody there? Atomic number 5. Atomic number 5. Got it? Alright, so what pops up is a picture of what it looks like, some basic information, but here's our element box up here too. So we see our atomic number 5. What's this number right here? Okay?
Atomic mass.
The atomic mass. What's different about these atomic masses than what you had on your periodic table from last Friday? What's different, Mackenzie?
Is there like
Brackets? Well, besides the brackets, the number itself, what's different? What's different, okay?
it moved up? It's on the top instead of the bottom.
Okay, so it changed positions, but what about the number itself? What do we have in this number that we didn't have last Friday? Robert? The decimal places. We didn't have any of these decimal places last Friday, did we? You think that's going to be important? Yeah, it's probably going to be important. All right, so our atomic number is 5. So let's build this thing. See the little green button up there where it says build? Everybody touch on build.
This is the atomic sandbox. Add protons, neutrons, and electrons to build a stable atom.
All right, so
The
we're
number
going...
of protons is the atomic number and determines the element you have. To determine the number,
We don't want to listen to that right now. All right? We're going to build this thing right over here, and I know this is really teeny tiny. You can see it better on your screen. Here's our atomic number, which is what? 5. And our atomic mass, which is? 10.81. Down here is where our protons, our neutrons, and electrons are. If the atomic number is 5, how many protons does this thing have?
5.
All right, watch this. Hopefully he's through talking. Yeah, he's through talking. I'm going to come right down here. And I'm going to add 5 protons to that thing. If the atomic number is 5, and we know it has 5 protons, what else do we know?
5 electrons.
Kids?
5 electrons.
5 electrons. So our electrons are over here, so I'm going to add 5 over here. And see how it's keeping track right here? Keeping track right here. If you accidentally get one too many, see I added 6 to that one, you can come back to your minus sign right here and watch what happens. It shoots it out of there. All right. Neutrons. neutrons. How do we find the neutrons? What's our formula, Sky?
Proton minus electron.
Nope.
Ah.
Nope, close. Very close. Robert?
Proton plus electrons.
No. Because we're looking for neutrons. It's that subtraction formula. What is it, Parker?
Atomic weight minus the atomic mass.
Atomic weight and atomic mass are the same thing.
Oh.
Getting closer, though. Mackenzie?
Atomic weight and atomic number.
So atomic weight minus the number of protons, which is also the same as
5.
the atomic number, right? All right, so what do we have here? 10.81 minus 5. So how many neutrons do we need?
5.
5? We'll put 5 in there and let's see what happens. When you think you have it correct, you're going to hit submit. Hit the submit button and see what happens. Oh, so what happened?
Oh gosh.
Watch this. Everybody watching up here. You ready? If you don't build it correctly, look what happens here.
Oh, I built it
Oh.
correctly. My brain started.
It puts you on a timer, but where did we mess up? We messed up because of this decimal thing over here. 10.81. Is that round to 10 or does it round up to 11? It rounds up to 11, so how many neutrons should we have?
11.
We should have 6. 11 minus 5 is, so I'm going to add another neutron there, but I'm going to, look what happens if you don't build it in time.
I got it.
I didn't get it built correctly in time, and I ran out of time, it exploded, now I got to start all over again. Okay, but I'm going to go ahead and build mine very correctly, real fast. Is that 4 or 5? 5, 1, 2, 3. Now I have it built correctly. Watch what happens when you get it built correctly.
Well done.
Well done.
This is awesome.
And watch what happens when you hit on continue. It takes you back to your periodic table. And everybody watch here. To get rid of this, just touch on your screen right here somewhere. And look at that little bitty hammer right there. Everybody see that hammer?
Yeah.
That means you have built it successfully. Think you got it?
Yeah. Do we build like everyone?
No, wait a minute. So
Oh.
here's the guidelines for today. You're going to start right here at number 11. You cannot do 1 through 10. Those are too easy. You're going to start at number 11, and you're going to build as many as you can correctly. And everybody look over here at your grading scale. If you, by the time it's time to start putting things up, and we've got about, let's say about 35 minutes. You have 35 minutes to build as many as you can correctly. If you build 25 or more correctly, you're getting 100 today. If you go 22, 23, or 24, you're getting a 90. Here's your grading scale. I would suggest you start here and just kind of work your way through. Do you have to go in order?
No.
No, you don't have to, but the farther down here you get with the bigger numbers, they're going to take a little bit longer because you have to sit there and count. Okay? You're doing as many as you can. I'll tell you right now, first hour, there were 5 or 6 kids that did 40 or more, completed 40 or more of them correctly. So that's kind of your target numbers, okay? It's 40 or more. Anybody have any questions? Now, this is going to be the only day that you can turn your volume up and not have your headphones plugged in, and everybody can be sounding like a video game. This is going to be the only day I'm going to let you turn your volume up and make noise with your outfits, okay? So you don't have to have your headphones in. You don't have to use your headphones.
I've already built 2.
And you can unplug and turn your volume up, and we'll listen to everybody shooting at electrons and protons and neutrons. Think you got it? All right, go.